Hello students, welcome to my channel Master at Mania by BBC. This is my first YouTube video. You may face some problem since this is my first video, and later we shall improve those mistakes in my next videos. So in this video, I shall discuss some important concept from the chapter Relation. This chapter is very useful for the students of different universities like Calcutta University, North Bengal University, Bardhaman University, and many more. Okay? And if you understand the concept of this chapter, kindly subscribe to my channel and I shall prepare more and more videos like this so that students get benefited for their university exams. Okay? So there is the first part of the relation. In this part, we shall understand some important concept of this chapter, okay? Because the concept of this chapter is very helpful. At first, you have to understand the concept. After that, you can solve the questions from this chapter. So in today's class, we shall discuss some important concepts from this chapter. And in the next part of the video, I shall discuss some important questions from this chapter. Okay? So we start with the chapter relation. Okay? So at first, we have to understand what is the concept of relation. Okay. Okay. So relation means what? See that the word relation basically implies a logical association. A logical association between two things. What is the meaning of relation? The meaning is okay. It means a logical relation. Logical relation, that means where a relation can be established, মানে একটা রিলেশনশিপ তোমাকে পেতে হবে, okay? You have to find a relationship between two variables, say, okay? You must find a relation between two variables. তোমাকে variables গুলোর মধ্যে relation পেতে হবে. You can't consider a relation which is not logical. Take an example. If we give an example from real life, see that we may find a relation between smoking and cancer. Okay, we may assume that smokers have a higher chance of getting cancer. যারা বেশি স্মোক করে তাদের ক্যান্সার হওয়ার চান্সটা হাই, we may assume. Okay, that doesn't mean it is true, but this type of logical relation, there is a logic. You can relate smoking and cancer. So this type of logical relation is known as relation. Okay, this type of logical relation is known as relation. Suppose, for example, we define a relation smoking and rain. Is there any relation between smoking and rain? I think no. So there is not a logical relation. So relation means a logical relation. You have to find a relation, okay, where there are some logic. এমন কোনো রিলেশন আমরা নিতে পারবো না যেখানে কোনো লজিক নেই। ফর এক্সাম্পল, যেটা আমি বলছি স্মোকিং অ্যান্ড ক্যান্সার, অবভিয়াসলি দিস রিলেশনশিপ ইজ লজিক্যাল। Now these are real life example, but in our university course, okay, now coming to the main point. Now what university course, how we can define relation? This is a logical example, okay, logical example or real life example. Now forget this example, this is only for concept. Now coming to the main point, okay, which type of question is more expected and what concept that we need to, okay, we need to understand that now. Okay, that concept now I am going to discuss. So starting, okay, coming to the main point, relation to a set. Okay, or you can, or you can consider this relation to a set, or otherwise you can take it as relation from one set to the other. So we are going to discuss this type of relation. So the thing is, suppose A and B, these are two sets. Now coming to the main points. Suppose A and B are the two sets, okay, and let R, what is R? Let R be the subset. let R be the of subset of A cross B. What is A cross B? A cross B is basically called Cartesian product. Recall Cartesian product. What is Cartesian product? Okay, so R is what? R is the subset of A cross B. Okay, now what is Cartesian product? See that, take an example of Cartesian product at first. Okay, at first we are defining Cartesian product. Suppose this set capital A is 1, 2 and another set B is 2, 3, 4. Say, at first we have to understand what is Cartesian product. We know Cartesian product from our HS course. Okay, suppose a set capital A is 1, 2 and another set B equal to 2, 3, 4. Now we can define Cartesian product A cross B. Okay, like A cross B equal to, we can define Cartesian product. It is 1, 2, take all possible pair, or okay, say that take all possible pair like this, A, 2, then what? Sorry, 1, 2, then 1, 3, then 1, 4. Say that 1, 2, 1, 3, 1, 4. Then what? 2, 2, 2, 3, then 2, 4. This is called Cartesian product of two sets. 1, 2. That means choose one element from this set and another element from this set. This is called Cartesian product of two sets. Okay. So this is the all possible Cartesian product. 1, 2, 1, 3, 1, 4, then 2, 2, 2, 3, 2, 4. Okay. Then R is what? R is the subset of A cross B. That means R is a subset. Recall, this is the symbol of subset. Okay. If we define this symbol, it means proper subset. And if we give this equality sign, this is called subset. Okay. So R is what? R is a subset of this Cartesian product. R be the subset of A Cartesian product B. Okay, done. Then what? Then what is relation? Now we can define relation. Okay, we understand the concept of Cartesian product. This is our Cartesian product. Now we can define relation quite easily. So what is relation? So relation is a subset R. What is relation? A subset capital R. We are taking a subset capital R of A Cartesian product B, as I have defined earlier. Okay, a subset capital R of A Cartesian product B is called a relation. This is the definition. Is called a relation. Is called a relation. Okay. A subset R of this Cartesian product A cross B is called a relation. Then we can, okay, for example, consider the previous example where we have taken A cross B like this. 1, 2. Then our set A was 1, 2, and our set B was 2, 3, 4. We define Cartesian product 1, 2, 1, 3, 1, 4. Okay. Say, consider this example. A equal to 1, 2, B equal to 2, 3, 4. Then 1, 2, 1, 3, 1, 4. Then 2, 2, 2, 3, 2, 3, and 2, 4. Say this is my A cross B. Okay. Then we can take any subset of this. Any subset. Take any subset of this. Say we are taking the subset R. This. Say 1, 2, 1, 3, 1, 4. Okay. We are taking this set 1, 2, 1, 3, 1, 4. This is our set, and clearly there is a proper subset of A cross B. See that is a proper subset because we have taken only these three elements. You can take more like this. You can take more elements like this, but we have taken only these three: 1, 2, 1, 3, and 1, 4. Okay. In that case, we say that R is a relation. In that case, we say that R is a relation from A to B. R is a relation from A to B. We say that R is a relation from A to B. You can take any subset like this. Okay. Now see that in this subset the members are 1 2 1 3 1 4. Okay. You can easily see that in this set the members are 1 2 1 3 1 4. So we say that 1 2 1 3 1 4 are in a relation. Okay. We say that 1 2 1 3 and 1 4 are in a relation. Okay. And we write them as 1 related to 2, 1 or 2. 1 is related with 2 because in this relation 1 and 2 is present. Similarly, we can say that 1 is related to 3 or 1 is in relation with 3 and so on. Okay. See that 2 comma 3 does not belongs to R. Right? 2 comma 3 does not belongs to R. So we also say that 2 is not related to 3. 2 is not related to 3 like this. Clear? Because in this subset only 1 2 1 3 and 1 4 are present. So we say that 1 2 1 3 1 4 are in a relation. And we write them like 1 related to 2, 1 related to 3 and so on. And here see that 2 comma 3 is not in a relation. So we say we write 2 is not related to 3. Okay. So it's a very important example. In this example, you can clear your concept. Okay. If you understand this example. And if you face any problem, you can text me. Okay. I shall clear your doubt in my next video. If you face any problem related to this concept, you can text me. Okay. And I shall clear your I shall clear your doubt in my next video. So there is the concept of relation. So in general, suppose an element A belongs to the set capital A. Suppose an element A belongs to the set capital A and another element B belongs to the set capital B. Say, okay. Suppose an element A belongs to the set capital A and another element B belongs to the set capital B. Say, now if they are in a relation, we can write A is related to B. This is the general notation. Suppose an element A belongs to capital A, B belongs to capital B, and if they are in a relation, we say that A is in relation with B. Done. So this is the important concept of relation. Now, second important concept, domain and range. Next important concept, domain and range of a relation. Domain and range of a relation. What is domain and range? See that I shall give you some example on it. Suppose R is a relation. Always suppose R is a relation from A to B. Suppose capital R is a relation from A to B. Okay. We define the set D. We define the set capital D is equal to collection of all X. See that? Collection of all X. Note this point X. Such that, colon means such that, collection of all X such that X, comma Y. This pair belongs to R. R means relation. And relation means subset of A Cartesian B. Collection of all X such that X, comma Y, this pair belongs to R for some Y belongs to For some Y belongs to B. For some Y belongs to B. I am giving you an example. Similarly, what is range? If we define what is range, range equal to collection of all Y. Note this fact, it is Y. Domain means X, but range means Y. For range, What is range? Range is collection of all y such that x and y are in a relation. That means xy belongs to R. For some x belongs to, yes, A. For some x belongs to A. So take an example. If we take an example, suppose our set capital A, consider a set A, this is equal to 1, 2, A, x. Suppose we have a set capital A equal to 1 to ax and another set B is equal to 1 to ax and another set is 2, 3, C. Say these are two sets A and B. We consider a relation capital R. We consider a relation capital R. We know that what is relation? Relation must be a subset of Cartesian product. We know the all possible Cartesian products are what? 1, 2, 1, 3, 1, C, 2, 2, 2, 3, 2, C, and many more. We know this concept, okay? We have already discussed about this Cartesian product. আমরা already দেখো আমরা এই Cartesian product আমরা discuss করেছি. What is Cartesian product? So if you go through that definition, you can easily find this Cartesian product. And what is R? What is the relation? We know relation is any subset of this Cartesian product. You can choose any subset according to your convenience. তোমার যা ইচ্ছা হয় তুমি choose করতে পারো Cartesian product গুলোকে. Suppose I am taking the Cartesian product 1, 2, then 1, 3, then say A2. See that A2 is a possible Cartesian product. AC, say I am taking only this four. I again repeat, you can take any Cartesian product according to your convenience. Suppose I am taking this 4 Cartesian product. So you know that this Cartesian product is a relation, is okay, must form a relation because this is obviously a subset of A cross B. You can find A cross B. You can easily check this Cartesian product is a subset of this A cross B. Clear? Then what is my domain? Now question is, what is my domain? See that by definition of domain, it is the collection of all x. X means that comes first. Remember this trick. What is x? X means that comes first. Here 1 comes first, that means 1 is my x. Okay, that means it is the member of the domain. Then again 1, you don't need to write 1 again. Once you write 1, you don't need to write it again. So 1 is a member of my domain. Then any other member? Yes, A. See that, and another member is A. This A is repeated. We shall write only once. So these two are members of the domain because domain is all possible collection of x, and x means that comes first. যে তোমার ফার্স্টে থাকে সেটা তোমার হয়ে যাবে হচ্ছে domain. Okay, so our in domain 1, A, these two are the members. And for the range, look at the definition of range. We can see that range is the collection of all y. Okay, recall this definition. Range is the collection of all y. And we know y always comes second. That means there is the position of y, x, y. Okay, we always maintain this position x, y. So y under y 2 is a member. Under y 3 is a member. Under y, see that this 2 is repeated. Don't need to write. C is another member. So 2, 3, C, these 3 are members of my range. Clear, everyone? Okay, I again repeat, if anyone have any doubt, you can text me in my channel. Okay, I shall make another video on your doubt. So this is called example of domain and range. So domain means collection of all x and range means collection of all y. Okay, so these are some basic concept on relation. Okay, basic concept on relation. Now we shall discuss most important part from relation. From this part, you shall get so many questions in your university exams. Okay, so starting with the main portion of relation, this is called different type of relation. Different types of relation. Different types of relation. Okay, এখানে আমরা ডিসকাস করব কি নিয়ে? আমরা ডিসকাস করব হচ্ছে ডিফারেন্ট টাইপ অফ রিলেশন নিয়ে। কি কি টাইপের রিলেশন হতে পারে? All possible type of relation, and I shall give you examples on them. First type of relation, it is called reflexive. First type of relation is called reflexive relation. What is okay? We know what is relation. Always remember, relation is simply a subset of Cartesian product. Any subset of Cartesian product can be taken as a relation. But in exam, a particular relation will be given. Exam আমাদের একটা relation দেওয়া থাকবে. Okay, in exam a particular relation will be given, and we have to answer the question on the basis of those relations. Okay, so starting with the main portion of the relation, our first type of relation is called reflexive relation. What is reflexive relation? What is the definition of reflexive? Okay, the definition is a relation or the definition is a relation or on a set A, a relation or on a set capital A is called reflexive. Is called reflexive. Okay, I'm giving you a shortcut form reflexive. A relation R on a set capital A is called reflexive if A comma A. That means if it is A, that means there is your domain. We know what is domain. If domain is A, your range is also A. A to A. Suppose, okay, so it's a reflexive when if A comma A belongs to R, for all, there is the notation for all A belongs to A. So what is the definition of reflexive? The definition is if A belongs to capital A comma A belongs to R. A comma A must belongs to R relation. Take an example. Suppose we are given a set A is equal to 1, 2, 3. Okay. Suppose we are given a set capital A equal to 1, 2, 3. And suppose we define a relation like this: collection of all x, y such that mod of x minus y less than equal to 10. Okay. We are given a relation R is equal to collection of all x, y. This is called collection of all x, y such that means such that such that mod of x minus y less than equal to 10. What is the meaning of colon? Colon means such that modulus of x minus y less than equal to 10. Is this relation is reflexive? This is the question. Is this relation is reflexive? See that. We shall check whether this relation is reflexive or not. For this, take a member from the set capital A. This means small a belongs to capital A. That means take a member from the set capital A. Say we are taking the member 1. 1 obviously belongs to capital A. Now we shall check whether 1 comma 1 belongs to this relation or not. We shall check whether this 1 comma 1 belongs to this relation or not. For this, we are taking 1 comma 1, 1 comma 1. Okay, we are taking the pair 1 comma 1. Now for this pair 1 comma 1, we can see that if we put see that here x is 1, y is also 1. So put x equal to 1, y equal to 1 here. We are getting modulus of 1 minus 1. Now modulus of 1 minus 1 means 0, obviously 0. And we know 0 is always less than 10. Obviously 0 is less than 10. That means this criteria is satisfied. And this criteria is called relation. We see that this relation is satisfied for the pair 1 comma 1. That means we say that 1 comma 1 belongs to R. Okay, 1 comma 1 belongs to R. For reflexive, so what is the trick? For reflexive, see that your domain and range should be equal. Right? There is a domain, there is a range. So here domain is 1, range is also 1. So 1 comma 1. 1 comma 1 giving you mod of 1 minus 1 equal to 0, and 0 is less than 10. That means yes, 1 comma 1 is a member of this relation. Similarly, take another value 2. 2 also belongs to this set. And if we take say 2 comma 2 this pair, because of the reflexive, we know that these two should be same. Put x equal to 2, y equal to 2, mod 2 minus 2 equal to 0. 0 is again less than 10. Okay. That means, yes, 2 comma 2 also belongs to relation. Okay. Similarly, you can check 3 comma 3 also belongs to this relation. Similarly, 3 comma 3 also belongs to this relation. That means we say that a comma a for all a. See that for all a, whatever be your a, for all a, your a comma a always belonging to this relation. তাই না? 1 comma 1 belonging to this relation, 2 comma 2 belonging to this relation, 3 comma 3 belonging to this relation. So for all a, whatever be your a is a member of this set. What is a? Is a member of this set. See that for any member of this set, we see that this pair belongs to this relation. That means it is reflexive. That means it is reflexive. Clear? Okay. So this relationship is reflexive. So it's a first important relation that is called reflexive relation. Coming to the next point, second type of relation, it is called symmetric. It is called symmetric. What is symmetric relation? Write down the definition. Definition is a relation, or I'm giving you a shortcut. REL means relation. A relation R on a set capital A. A relation R on a set capital A is symmetric. Is symmetric if if A is related to B, that means A is in relation with B. If A is in relation with B, it always implies B also in a relation with A. If A is in a relation with B, B also in a relation with A. That means if A related to B, then B also related to A. So it is called relation, symmetric relation. Okay? That is, in other word, you can write it as if A comma B belongs to R, this implies B comma A also belonging to R. A B যদি R এ থাকে, B comma A ও R এ থাকবে। ঠিক আছে না? A আর B যদি R এ থাকে, তাহলে B comma A ও তোমার কোথায় থাকবে? R এ। So আগের এক্সাম্পলটা একটু দেখা যাক। If we consider the relation given in my previous example, mod of x minus y less than equal to 10. It can be 10, 11, 12, whatever, that doesn't matter. 10, 11, 12, that doesn't matter. Mode of, okay, coming to the, coming to this point, this symmetric relation. Recall our previous example. R equal to collection of all xy such that mod of x minus y less than equal to 10. Is this relation symmetric? We have to check. Okay, we have to check whether this relation is symmetric or not. So how to check symmetric or not? We know if A comma B is in relation, B comma A also in this relation, must be in the relation, তাই না? A comma B যদি রিলেশনে থাকে, B comma A ও তোমার রিলেশনে থাকবে. If A comma B are in relation, B comma is also in relation. So how we can check that? Take any two member from this set. Okay, let A comma B belongs to a set capital A. Whatever be your set capital A. Suppose capital A is say 1, 2, 3, 4, 5. Okay, you can take any two member from this set. Any two. Say 1, 2, 1, 3, 1, 4. But you don't need to take like this. You don't need to take like this. Take any two member. A comma B belongs to A. A comma B can be 1, 2. A comma B can be 2, 3. A comma B can be 4, 5. Any two. Take A comma B from this set. Okay, we are taking A comma B from this set, and we assume and let A comma B also belongs to this relation. You must assume A comma B, say A comma B is in relation. That means what? That means we can put x equal to A and we can put y equal to B. That means we can take mod of A minus B less than equal to 10. Okay, now there is a property of modulus function. The property of modulus function is mod of minus x equal to mod x. Just remember this property. Modulus of minus x equal to modulus of x. So if we go through this property, see that what we obtain, mod of a minus b can be written as, if we take minus common, if we take minus common, we can write it as b minus a. If we take minus common, we can write it as minus of b minus a. Now, mod of minus x is mod x. That means mod of, say this is your x. Say x equal to b minus a. So mod of minus x is equal to modulus of x. We know this property. Mod of minus x, say this is your x. Mod of minus x equal to modulus of x. Less than equal to 10. Clear? Now, mod of b minus a less than equal to 10, it means what? Here x equal to b and y equal to a. That means we can write as b comma a is in this relation. Why? Because here our x equal to b, here our y equal to a. See that here our x equal to b and here our y equal to a. So we can write b comma a is in relation. Okay, দেখো আমরা লিখতে পারি b comma a এই রিলেশনই আছে। So assuming a comma b belongs to assuming a comma b belongs to R, we obtain b comma a belongs to R. That means it is a symmetric relation. It is a symmetric relation. Okay. So this is called definition of symmetric relation. So symmetric relation, that means if a comma b belongs to this, b comma a also belongs to this. ঠিক আছে? Clear? Anyone? Any doubt? And if we consider another example from symmetric relation, we know relation is what? Relation is simply a subset of Cartesian product. Consider the set capital A equal to 2, 5, 6, 8. Consider a set 2, 5, 6, 8. And suppose we define a relation like, we know relation is simply what? Cartesian product. Okay. So here we are taking only A. Suppose we are not taking any B. That means our Cartesian product will be what? A cross A. Suppose here B equal to A. Then our Cartesian product will be A cross A. A cross A means what? 2, 2. Say 2, 5, 2, 6, 2, 8, like this. 2, 2, 2, 5, 2, 6, 2, 8. Then and so on. 5, 2, 5, 6, 5, 8. We can write down this Cartesian product like this. Okay, we know how to write Cartesian product. Now suppose we are taking a subset from this set. We are taking a subset from this set. Say subset is R equal to. We are taking a subset from this set R equal to, say we are taking like 2, 6. We know there is a possible Cartesian product. Okay, there is a possible Cartesian product. Next, we are taking the Cartesian product 5, 6. We are taking the Cartesian product 5, 6. We are taking the Cartesian product 5, 5. Okay. Then we are taking the Cartesian product 6, 5. You can take all possible Cartesian product 6, 5, and we are taking the Cartesian product 6, 2. So we are taking the Cartesian product, first of all 2 and 6, 2 and 6, then 5 and 6, then 5 with 5, then 6 with 5, then 6 with 2. Question is this relation symmetric? Question is this relation is symmetric? Now we have to check this. How to check this? See that, first of all, take A comma B as 2, 6. 2, 6 belongs to R. 2, 6 belongs to R. This implies 6, 2 also belongs to R. And we see that 2, 6, 6, 2 both are present. Because symmetric relation means what? If A comma B is there, B comma A must be there. If A comma B is there, then B comma A must be there. So here 2, 6 is in this set, 6, 2 is also in this set. So yes, this is a symmetric relation. For the second example, see that 5, 6 is there, 6, 5 is also there. That means here symmetric. Up to this symmetric. Then 5, 5. See that if 5, 5 is there, yeah, this is x and this is y. Interchange x and y. That means we know if x, y is in relation, y, x must be in relation. That is called symmetric. Here, x is 5, y is 5. Interchange them. Y, x তাহলে কি হবে? My y, x is also 5, 5. And you can see that 5, 5 is also there. We are interchanging position of x and y. Here, y is 5, x is 5. So if 5, 5 is x, y, x is also 5, 5. And this 5, 5 is also present. That means yes, it is a symmetric relation. Because 2, 6 is present, 6, 2 is also present, 5, 6 is present, 6, 5 is also present, and 5, 5 means again 5, 5 if we interchange x and y. So this relationship is symmetric. Okay, done. It is a symmetric, but see that if we discard this element from this set, suppose now we are considering the relation like this. Is this symmetric? Answer is no. Answer is no, because here 2, 6 is present, but 6, 2 does not. Here 2, 6 is present, but 6, 2 does not. 2, 6 ache, but 6, 2 নেই. That means it is not symmetric. So this set is not symmetric. If we add 6, 2, then it becomes symmetric. Okay? This is the concept of symmetric relation. And our third and final important relation is transitive. Transitive relation. What is the definition of transitive relation? Transitive. Okay, symmetric. Then our third type of relation is symmetric. After first one is reflexive, second is symmetric, third is transitive. What is transitive relation? Suppose A is in relation with B. A is in relation with B and B is in relation with C. These two are given. A B এর সাথে রিলেশনে আছে, B C এর সাথে রিলেশনে আছে. A is in relation with B, B with C. If this implies A, C also is in relation, A B এর সাথে রিলেশনে আছে, B C এর সাথে রিলেশনে আছে. If this implies A, C also is in relation, you have to assume this, you have to show this. A, C also is in relation, this implies transitive. That means assume two element A, B belongs to R, B, C also belongs to R. This implies A, C also belongs to R. If this hold, we say that this is transitive relation. Okay. Take an example. We shall again consider our previous example. Okay, the example of modulus of x minus y less than equal to 10. Consider the relation R equal to collection of all x, y such that modulus of x minus y less than equal to 10. Is this relation transitive? For this, take any two element A, B belongs to R. This is given. A, B belongs to R means what? Mod of A minus B less than equal to 10. Next, take another two element B, C belongs to R. It means mod of B minus C less than equal to 10. We are assuming this. We are required to show A, C also is in relation. আমাকে কি শো করতে হবে? আমাকে শো করতে হবে যে A, C এরাও তোমার রিলেশনে আছে. We need to show A, C also is in relation. How we can prove this? How we can show this? A, C also is in relation. For this, we need to show modulus of A minus C less than equal to 10. Right? Modulus of A minus C less than equal to 10. Now, how we can show this? Proof. We need to show these two are given. Always remember, these two are given. We need to show A, C is in relation. That means mod of A minus C less than equal to 10. How we can show this? We start with mod of A minus C. Okay. How we can write mod of A minus C? See that mod of A minus C can be written as mod of A minus B we are subtracting b and we are adding b. That we can easily done. We are subtracting b, we are adding b. Okay? Then what? Now there is a relation that is called triangle inequality. Okay? That is a result. It is called triangle inequality. This inequality says mod of x plus y. This inequality says mod of x plus y less than equal to mod x plus mod y. Okay? This is called triangular inequality. Okay, triangular inequality. This inequality says mod of x plus y less than equal to mod x plus mod y. Remember this inequality. So if we apply this inequality, take this one as x, this one as y. Okay, take this one as x and this one as a y. So modulus of x plus y. See that modulus of x plus y. This will be less than equal to modulus of x plus of modulus of y. So that mod of x plus y, this is less than equal to modulus of x plus of modulus of y. So less than equal to modulus of x, this is your x plus modulus of y. So less than equal to modulus of a minus b plus of modulus of b minus c. Done? Okay. Clear now? Mod of x plus y less than equal to mod x plus mod y. Now what? Now mod of a minus b less than equal to 10. It is given. Mod of a minus b less than equal to 10 plus mod of b minus c. It is also less than equal to 10. Clear now? Mod of a minus b less than equal to 10. Mod of b minus c less than equal to 10. Now 10 plus 10 giving you 20. 10 plus 10 giving you 20. So what we obtain? We obtain mod a minus c less than equal to 20. Okay? Mod of a minus c less than equal to 20. Clear? Anyone? Any question? Mod of a minus c less than equal to 20. Because 10 plus 10 giving you 20. Now, can we say that mod of a minus, but see that we need to show mod of a minus c less than equal to 10. Now, does less than equal to 20 implies less than equal to 10? My question is, if a number is less than equal to 20, does it imply that number is less than 10 as well? Answer is no. Why? Suppose the value of, for example, the value of mod of a minus c is 15. See, suppose the value of mod a minus c is 15. Here, 15 less than 20. So this relation is satisfied. But 15 less than 10, it is not true. Okay, again repeat, see that. Suppose the value of mod a minus c is 15 and 15 is less than 20. Okay, obviously 15 is less than 20. But can you say 15 is less than 10? Answer is no. That means we can't say, we can't say mod of a minus c is less than equal to 10. Okay, we can't say mod a minus c less than equal to 10 because we have proved that mod a minus c is less than equal to 20. But that does not imply mod a minus c is less than equal to 10. That means this property does not hold. And we say that this relation is not transitive. This relation is not transitive. Okay. This relation is not transitive because our purpose is to check mod a minus c less than equal to 10. But we have proved that mod a minus c is less than equal to what? Less than equal to 20. But less than equal to 20 does not mean less than equal to 10. That means it is not a transitive relation. Okay, clear? So there is not a transitive relation. And note reflexive plus symmetric plus transitive. If all the conditions hold, see that if all the conditions hold, reflexive, symmetric, and transitive, we say that this relationship is equivalence. This is called definition of equivalence relation. What is the definition of equivalence relation? Answer is, if a relation is reflexive, symmetric, and transitive, all all should satisfy. We say that this relationship is okay, equivalence. This is called definition of equivalence relation. Okay. In our previous example, we have seen that our relation was reflexive. আগে যে এক্সাম্পলটা ছিল সেখানে দেখো রিফ্লেক্সিভ রিলেশন স্যাটিসফাই করে গেছে। Symmetric relation also satisfied in our previous example, but we have seen that this transitive relation does not hold. ওই যে এক্সাম্পলটা ছিল না, mod of x minus y less than equal to 10, whatever be our set, mod of x minus y less than equal to 10, we can say that in this example, we have seen that this relationship was reflexive, symmetric, but this relationship is not transitive. Okay. So that means this relationship is not equivalence. But see that this always depend on your set. For example, if our set is given like this, suppose our set is 1, 2, 3, 4, 5. Okay. Suppose our set is 1, 2, 3, 4, 5. Here you can see that always mod of x minus y less than equal to 10 is satisfied. Okay. But it is not always. That always depend on this set. So if our set like this, here we always say that mod of x minus y less than equal to 10. But if our set contains more elements, say 1, 2, up to 100, say up to 100, here this relation does not always hold. For example, if we take x equal to 1 and y equal to 100, sorry, 100. If we take x equal to 1, y equal to 100, mod of 1 minus 100 giving you mod of minus 99. And we know mod of minus 99 is only 99. And 99 is not less than 10. 99 is not less than 10. So it depends our set. Okay. So this is the definition of equivalence relation. Okay. So if all the properties hold simultaneously, reflexive, transitive, and symmetric, we say that it is equivalent. And our next important topic, equivalent class. Okay, and okay, you can say this equivalence. Equivalence class. Equivalence class. What is equivalence class? At first, I'm giving you definition of equivalence class, then some important example. Suppose a relation R is reflexive, symmetric, transitive, all. That means suppose our R is equivalent. Okay. Suppose R is equivalence relation. That means R is symmetric, reflexive, transitive, all. Suppose R is an equivalence relation. Okay, and let capital A is the given set. Given set is capital A. Suppose small a is a member of this capital A. That means small a is a member. Small a is a member of this set capital A. Then we can define equivalence class. Then we can define equivalence class by this notation third bracket A. Third bracket A means what? Third bracket A means the members which belongs to equivalence class of A. All the members, third bracket means all the members that belongs to equivalence class of A. For example, we can write this as third bracket A is equal to collection of all x such that x belongs to capital A. Collection of all x such that x belongs to capital A and A comma x belongs to relation. That means third bracket A equal to all collection of all x such that x and A is in relation. If this hold, we say that it is an equivalence class. Okay. Take an example on it. If we consider an example, it will be easy for us. Okay. So I'm giving you an example on this equivalence class. Okay, I'm giving you the example of equivalence class. Suppose our set capital A, we consider, okay, in equivalence class, at first see that the okay, in the definition of equivalence class, we say that we must consider a set, then a relation. Suppose our set is 1 comma 2 comma 3. Suppose we have a set capital A is equal to 1 comma 2 comma 3, and let our relation are given by 1 comma 1, 2 comma 2, 3 comma 3. Then take some more elements, 1 comma 2, 2 comma. Okay, done. Suppose our set in, okay, equivalence class means we have to consider a set, and we have to consider relation. Suppose we are considering a set 1 2 3, and we are considering a relation 1 1 2 2 3 3 1 2 2 1. Say clearly you can say that this R is a subset of A cross A. You can find A cross A yourself. If you find any doubt, you can ask me. Okay, you can find A cross A at first. You can see that all these members are the element of A cross A. You can check yourself. Okay, but I am not taking all the elements of A cross A. Okay, I am taking only this few elements. Okay, I am taking these few elements. Then, then at first we shall take A equal to 1. That means we shall find the equivalence class of this element 1. Okay, what is the first target? Our first target is to find equivalent class of this element 1. How we can find that? Equivalence class of 1. It means what? It means the elements that belongs to equivalence class of 1. Okay, how to find that? How to find the elements that belongs to equivalence class of 1? Okay, for this we have, okay, so we have to go to the definition. Equivalence class means, equivalence class of 1 means all those elements which are in a relation with 1, which have a relation with 1, all those elements, okay, which have a relation with R, with 1, সে সমস্ত এলিমেন্ট যাদের 1 এর সাথে রিলেশন আছে, সে সমস্ত এলিমেন্ট যারা 1 এর সাথে রিলেটেড। For this example, see that 1 is related to 1 because 1 comma pair is 1 comma 1 is present. That means in equivalence class of 1 we must have 1. Then see that 1 is related to 2, then equivalence class 2 must be present. But see that there is no relation between 1 and 3. That means 3 will be absent in this class. Okay, 2 will be absent in this class. Okay, done. Anyone, any confusion? Okay, see that this is called equivalence class. I can repeat, you have to consider all those elements, you have to consider all those elements which, okay, which are in a relation with that element. Okay, you have to consider all those elements which have a relation with that element. So here I am taking at first 1. We can see that 1 has a relation with 1 because 1 comma 1 is present. 1 has a relation with 2, so 1 comma 2 must be there. Then what is the equivalence class of 2? See that 2 is related to 2. That means in equivalence class of 2, 2 must be there. 2 is related to 1. So in the equivalence class of 2, 1 must be there. But see that 3 is also absent here. And finally, the equivalence class of 3. See that 3 is related with 3 only. 3 is related with 3 only. That means in equivalence class of 3, only 3 will be there. Okay, these are called equivalence class. Okay, this is the example of equivalence class. Anyone, any confusion from this? This is called equivalence class. Another example of equivalence class. Suppose we have a set 1 2 3 4 5. Suppose we have a set 1, 2, 3, 4, 5. Okay, we are taking the set 1, 2, 3, 4, 5. Now we are taking we are considering the relation. We are considering the relation collection of all x comma y such that we are okay. I'm giving you example. We are taking this set 1, 2, 3, 4, 5, or whatever be your set, and we are taking the relation R is equal to collection of all x comma y such that modulus of x minus y is divisible by modulus of x comma y is divisible by 2. Modulus of x minus y is divisible by 2. Then we have to check which element belongs to equivalence class of all these elements. Okay, we have to check which element belongs to equivalence class of all these element. আমাদের কি চেক করতে হবে? আমাদের চেক করতে হবে যে কারা কারা এদের ইকুইভ্যালেন্স ক্লাসে বিলং করছে। ওকে, দ্যাট উই নিড টু চেক, যে কারা কারা এদের ইকুইভ্যালেন্স ক্লাসে বিলং করছে। তো সেটা কি করে চেক করব? হাউ উই ক্যান চেক দিস? See that at first we are taking equivalence class of 1. Equivalence class of 1. Okay. Question is whether 1 belongs to equivalence class of 1. For this, put x equal to here, take x equal to 1. Y is also 1. Mod of 1 minus 1, which is 0. Take x equal to 1, y equal to also 1. So mod x minus 1, mod of 1 minus 1, which is 0. Now, 0 is clearly divisible by 2. Clearly 0 is divisible by 2, which is divisible by 2. That means equivalence class of 1 is 1. Now take another element 2. Thus 2 belongs to equivalence class of 1. For this, take x equal to 1 and y equal to 2. Mod 1 minus 2 is mod of minus 1. Mod of minus 1 means plus 1. Mod of minus 1 means plus 1. Okay. Now question is whether 1 is divisible by 2. Answer is no. 1 is not divisible by 2. So 2 does not belongs to equivalence class of 1. Similarly, take element 3. Mod of 1 minus 3 giving you mod of minus 2. Mod of minus 2 means plus 2. And 2 is divisible by 2. So in equivalence class of 1, 3 is a member. Similarly, if we take 4, 1 minus 4 giving you 3. And 3 is not divisible by 2. So 4 does not belongs to this class. Similarly, take the element 5. 1 minus 5 giving you 4. And 4 is divisible by 2. So 5 is also a member of this. Similarly, for equivalence class of 2, equivalence class of 2, here we shall take x equal to 2. At first, take y equal to 1. More, we are taking x equal to 2, y equal to 1. Mod of 2 minus 1 is 1. Now 1 is not divisible by 2. That means in equivalence class of 2, 1 is not present. 2, if we put x equal to 2 and y is also 2, 2 minus 2 is 0 and 0 is divisible by 2. So 2 is a member of this class. Then 3, if we take x equal to 2 and y equal to 3, mod of 2 minus 3 is mod of minus 1, which is plus 1. And we know 1 is not divisible by 2. So 3 is not a member. Similarly, 4 is a member because if we take x equal to 2, y equal to 4, mod of 2 minus 4 equal to mod of 2. Mod of 2 is 2. If we put x equal to 2 and y equal to 4, mod of 2 minus 4 is mod of minus 2, which is plus 2. And 2 is divisible by 2. So 4 is a member. Similarly, you can check 5 is not a member because 2 minus 5 করলে কি হবে? 2 minus 5 giving you 3 and 3 is not divisible by 2. So equivalence class of 2 is only 2, 4. Okay, and so on. Like this, you can find all the equivalence classes. Okay, you can find all the equivalence classes like this. Clear? So these are okay. This is a very important example on equivalence class. And from this, a very important result is there. First result is two equivalence classes two equivalence classes are either disjoint. Two equivalence classes are either disjoint. Two equivalence classes are either disjoint or identical. Two equivalence classes are either disjoint or identical. So very important result. I shall give you a proof in my next class. Two equivalence classes are either disjoint or identical. Why? Take this example. Two equivalence classes are either disjoint. Disjoint means they have no common value, or identical. Identical means what? Identical means they are equal. Identical. So you can verify this from the previous example, but there is a proof of this result. I shall give you the proof in my next class. See that equivalence class of 1 is 135, equivalence class of 2 is 24. Similarly, you can check equivalence class of 3. Equivalence class of 3 would be 1, because 1 minus 3 means 2 and 2 divide 2. 3 minus 3 giving you 0 and 0 is divisible by 2. And 5, because 5 minus 3 giving you 2 and 2 is divisible by 2. Equivalence class of 4. Equivalence class of 4 is only 2 4. And equivalence class of 5. Equivalence class of 5 is what? Equivalence class of 5 is again 135. You can check yourselves. Very easy to check. Okay. So the result is two equivalence classes are either disjoint or they are identical. See that if we consider these two equivalent classes, see that they are identical. 135, 135. Again, see that these three are identical. And basically, we can write equivalence class of 1 is equivalent to equivalence class of 3 equal to equivalence class of 5. Because these two equivalence classes are identical. Their members are 1, 3, 5. Their members are 1, 3, 5. Also, you note that equivalence class of 1 and 2 are totally disjoint. Because see that under equivalence class of 1, these three members are present. Under equivalence class of 2, these two members are present. Is there any common element? In equivalence class of 1, 1, 3, 5 are present. In equivalence class of 2, only 2 and 4 are present. Is there any common element? Answer is no. That means they are disjoint. Disjoint means their intersection is a null set. Disjoint means their intersection is a null set. That means we can write equivalence class of 1 intersection equivalence class of 2 is equal to 5. 5 means null set. Okay. So see that either two equivalence classes are disjoint. Here see that equivalence class of 1 and equivalence class of 2 are disjoint. Disjoint means they have no common portion. See that similarly you can see that equivalence class of 1 and equivalence class of 4, they are also disjoint. Their intersection is 5. Intersection 5 means they are disjoint. But see that equivalence class of 1 and equivalence class of 3 are identical. So we are getting only two possibilities. We are getting only two possibilities for equivalence classes. Either the equivalence classes are disjoint or they are identical. There is no other possibility. That means two equivalence class cannot have same member. Okay, if they have same member, they are identical. I again repeat, two equivalence classes cannot have same member. Common member, same common member. Same member means common member. If they have common members, they are identical. They will be totally identical. Otherwise, they will be totally disjoint. There is no other possibility. Okay, you can easily see this example. Okay. So this is everything from my first lecture video. If you understand the concept, just okay, you can share my video and subscribe if you like this video, and I shall prepare more and more videos like this. This is my lesson, okay, chapter 1, not lesson 1 or class 1. You can watch whatever you say. Class 1 from relation. I shall prepare next video on relation where I shall solve some important questions from different universities, okay, on relation chapter. Okay, I shall solve more and more examples on this chapter, and these questions will be very, very useful for exam purpose. And in this second video, I shall I shall discuss the concept of antisymmetric relation. So our next video will be on antisymmetric relation, number one. Number two, important examples on equivalence class and equivalence relation. Important example of equivalence class and equivalence relation. Okay. So our video stops here. Okay. So again, I shall meet with everyone in my next video.